Two more examples of working with reciprocal functions, integrals of reciprocal functions. Once again, you notice I have a fraction here. And again, we don't really have a quotient rule per se for taking the integral of a function. So really the only thing you have is this new idea that if there's a denominator, maybe we can write this as some type of a reciprocal. So again, I would encourage you to take your numerator, write it off to the side, write the cosine x over here, and write that as 1 over sine of x. Okay? The instant you see that, you realize, oh, reciprocal. That's a reciprocal of the sine function. Okay? That's going to be the natural log of the absolute value of sine of x, except I have to account for the derivative of the inside function. The derivative of the inside function here is cosine of x, and that cosine of x has to get pulled back into the function. Well, guess what? I've got a cosine of x out there with my dx already. So that's going to get reversed, pulled back into the function, divided out of the function if you want to think of it in those terms. So when I take my antiderivative, the derivative of the inside function, that cosine of x is going to get canceled. I'm left with just this plus my c. Okay? You come down to this example here. Oh, by the way, one thing that's also really important here, we know that sine of x over cosine x is equal to the tangent of x. That means that the cosine of x over the sine of x is equal to the cotangent of x. We just actually found the antiderivative of cotangent, okay, or the integral of cotangent. So you can see where some of those ideas might come from. Final example here. Again, horrible looking fraction, okay? When you see that, you say, I don't know a quotient rule for taking integrals, but I do have this new reciprocal function idea. Maybe if I can write it as 1 over some function, maybe the numerator's got something to do with the chain rule, okay? And so we're going to do the same thing here. I'm going to take that secant squared of 5x, I'm going to write it off to the side here with my dx, okay? What happens? Oh, 1 over tangent of 5x. That's a reciprocal function. I know that that's the natural log of the absolute value of that inside function, which in this case is going to be tangent of 5x, but I have to get rid of the derivative of the inside function. The derivative of the inside function here is going to be 5 secant squared 5x. You'll notice up here I don't have 5 secant squared of 5x, I have 1 secant squared of 5x. So I've got to put in a 5, and I've got to balance it by putting in a 1/5 over here. What happens when I take the derivative of the inside function gets reversed, it gets sucked back into that function, and you got the 1/5 sitting out here in front, and that ends up being your final integral. Again, make sure to put your plus c in there, but that's the basic idea. So if you see fractions, see if you can write it as a reciprocal, 1 over some value times something else. More often than not, that second part out there is going to have something to do with the derivative of the inside function, and these things can work out really well. But you have to recognize that this is a relationship that shows up when you have fractions, and if you don't think that to make that connection, some of these are going to be relatively challenging. So look for those patterns, everything will work out really nicely.